Good morning, this is your Stat Sensei, Mr. Spensei, and this is an exit ticket for reading computer printouts for regression. So, most important thing is to figure out where to start because there's a whole bunch of information in that computer printout. Always look for the word constant. Constant is where we start, as I've said before. So we're going to highlight the word constant, and that tells me my y-intercept row. After that, directly below it is always going to be, and it's always directly below it. We don't know where those two rows are going to show up. We just look for the word constant. But once we find constant, we know where the y-intercept row is. And we also, directly below it every single time, is the slope row. So the very first thing it asks for is the explanatory variable. Explanatory tells me x, all right? Because x, ex. So I'm going to go ahead and put an X there, even though I don't have to. And I go, oh, the explanatory variable is directly below the constant, and that happens to be age in months, what happens to be A. Then it asks for the y-intercept. Well, guess what? Y-intercept is on the y-intercept row. So looking for my y-intercept is right next to the word constant. So in this case, it's 4.8803. The next thing it asks for is slope. And the word slope tells me, oh, we must be looking at the slope row, and we are, and it's directly below the y-intercept, and that's 0.2671. As I've said before, the regression equation doesn't explicitly show up on the computer printout, but they give us all the information. And as I've said before, it's based on y equals mx plus b that you learned in Algebra 1, where b was our y-intercept and m happened to be our slope. But being statistics, we're going to change this up a little bit. And there's actually very good reasons why. And we're going to go y equals b plus mx. And although the calculator differs, this is the order we actually write it in. So since that's what we are already familiar with, I'm going to use that here. Well, b is our y-intercept and m happens to be our slope. So in this case, our regression equation, and we'll start off with by just writing the y hat equals, well, our y-intercept is 4.8803, and I'm going to shorten that up just so I have room. So 4.88, and our slope is positive, so plus 0.2671, and then we'll drop an x in there. All right, so that's our regression equation. The next thing it asks for is the standard deviation of residuals. And be careful, because sometimes this is referred to standard deviation, but this is standard deviation of the y-intercept or standard deviation of the slope. This asks for standard deviation of the residuals, and it's in a completely different spot. All right, standard deviation of the residuals is given by a capital S. All right, and it talks about the amount of variation we can expect. So in this case, we have 0.4703, and that comes from right here. That big S can be in all sorts of different places, but look for the big S. Big S is standard deviation of the residuals. The next thing, it says T statistics for the slope. And actually, if I look below it, it also says slope. So the fact that we have slope written down tells me we're looking for the slope row. Well, when I look, I go, oh, I have two T statistics, but it's specifically telling me that it wants the T statistic for the slope. So I need to pull the one off the slope row, and that is 6.7197. The next thing I'm going to need is the p-value for the slope. Again, I have two p-values, and this time they happen to be the same, but I specifically need the one off the slope row, which happens to be 0.000, and that's letter G. The correlation coefficient. The correlation coefficient isn't directly on there, but we have the information to do that. Now, to be careful, we're going to need a couple things. We're going to need two pieces of information. We're going to need sine of the slope. And obviously, if we're needing sine of the slope, that's going to be, I use the word slope, so that's going to be off the slope row. And we're going to need the square root of r squared. Okay, so let's start off with this case. Let's start off with the sine of the slope. Well, I look at my slope is positive, so my correlation coefficient is going to be positive. Technically, I don't have to put a plus sign, but we're going to do that just because we know this is positive. All right? Then it asks for r squared. Well, I have two r squareds. So that could be a little confusing, but do know that for this course, we'll never use r squared adjusted, so this isn't going to be it. It has to be this one. But I need to go ahead and take that percent and divide it by 100 because I'm going to take the square root of it. So 82.18 over 100. And you always divide percents by 100. So 82.18 divided by 100 is 0.8218. So I need to take the square root of 0.8218. Now, you can use the square root button. I like to just raise it to the half power, so raise it to the 0.5, and I get 0.9065. So my correlation coefficient is a positive 0.9065. All right, that concludes this video. I appreciate you watching and sure hope that helps. Forward to seeing you on the next one. Thank you.